Aloha, friends, and welcome to another update on the Kilauea volcano in Hawaii. I'm Geology Professor Shawn Willsey. Today is Wednesday, November 26th, and episode 37 has come and gone. This is a little footage here from last night when it was still erupting. Episode 37 began about 2:30 p.m. on Tuesday, November 25th, local time, ended at about 11:39 p.m., so about 9 hours or so of eruption. It totally erupted from the north vent, so a little different than the last few episodes we've seen, where we've seen both the north and south vents involved in the action. This one was just out of one of those two primary vents there in the crater at Halemaumau. We had a fountain heights up to about 600 feet or about 180 meters or so. And all of this was, all this activity we saw with episode 37, we had some lead-up activity going into this. We had some precursory activity, these overflow events caused by gas pistoning. There's about 76 of those events. So if you've been watching the webcams, you've seen these occasional overflows of the vent where the lava just kind of runs out of the vent and spills out onto the landscape. But very different than what we see here, where we have the lava fountaining. So I have a lot of cool things to share with you, including some interesting footage from the webcams last night, and then we'll look at some of the monitoring data and what might be in the cards in terms of looking forward to episode 38. Let's see here. So yeah, this was the view last night. This was about 5:53, just a little bit after sunset. The view there, just spectacular glow from the fountains out of the north vent, and you can see the lava just spilling out onto the crater floor. Of course, now the eruption is over, and so we just have darkness, of course, because it's still dark there, but just a little bit of glow there coming from the vent. So that magma is sitting not too far below the surface and just will need to be repressurized with some gas before we can have the next eruptive phase. Let me take you to some videos I have. Let me get these in the right order here. And let's look at these. Let's look at the onset of the eruption first. Let's see. Go to, yeah, this is the onset of the eruption. So here we are yesterday. This is looking from the north side of the crater rim, looking down towards the north vent, looking more or less to the south, maybe a little bit to the southwest. And you can see here, this is about 2:14 yesterday, so a little bit before the eruption began in earnest. And of course, what the USGS has been using as a measuring point for the onset of the eruption is when it really starts fountaining. So they're picking that time. But we did have some precursor activity. We can see the lava in the vent rising, and then here's where it starts to spill out of the vent. Becomes a little bit more gas rich, forming these kind of roiling domes like you see right here. And this is all sped up like 4 times. So this is a little bit accelerated just to get us to the action a little bit quicker. So it's more or less a 4 times the speed time lapse. So here we are looking at the vent moving forward through time. You can see the buildup here from the vent. These will eventually start turning into fountains once more gas-rich magma kind of leads into this thing. The whole thing reminds me a lot of how geysers tend to erupt. You'll tend to see it in a lot of geysers. The water level in the pit there kind of ebb and flow a little bit as more gas in terms of, like, you know, water vapor, steam bubbles are brought into it with a geyser. And then eventually you get to that phase where it actually starts jetting the water out of the vent. Similar kind of process, I think, to what we see here with the fountaining that's going on with these episodes for the past year or so. Maybe I'll skip forward just a little bit here so you can kind of see this building up. You can see the activity becoming a little bit more vigorous here at the vent. A lot more lava being pumped out, and then eventually reaches something like this. So this, you know, is what we see, the onset of the lava fountaining that takes place. They're going up a little bit more, sort of overwhelming this landscape here in the foreground. So this was the onset of the eruption, more or less what it looked like from the beginning. And they had to move the camera back a little bit because it was getting a little bit higher. And from this point on, the lava fountains just got higher and higher until they reached those heights I mentioned previously. So here's one little video I wanted to share with you And then a couple others that I found pretty interesting. This one here is going to be from a different camera. No, wait, this. Let's see. Sorry about this. Uh, Here we go. This is the one I was thinking of. So this camera here is going to be looking to the north a little bit here, and this one actually shows. So this is a little bit later. It's about 3:30, so maybe less than an hour later than those previous videos we saw. This is the north vent here, the one that's doing most of the action, but you can see the south vent is really close. I mean, it's a little bit of a red glow there. It never really got going, and so I think the takeaway here is maybe, looking at the numbers, which I'll share with you here in a second when we get to the USGS update, didn't have quite as much total volume of lava erupting. The fountain heights weren't nearly as high as some of the previous ones. And I think if it would have had a little bit more pressure, more of a lava output for this eruption, we would have seen the south vent joining in, but it was just pretty much the north vent here. So a couple things to look at here would be the wind. So the wind actually did some interesting things yesterday. There was kind of a light winds from the trade winds here, but imagine just all the things going on at this point. Maybe you got the light trade winds coming across this landscape. Of course, there's this circular crater, which could add some circulation and locally change the wind direction a little bit. Then you have the jetting of the lava upwards, so that's directing the air upwards. And then you also have the heat from this as well. And so just all this sort of conflicting air motion actually led to some really interesting vortices, and I guess you could call them like little mini tornadoes, or I guess we called them once a lava-nado. But you can start to see the tephra getting kind of whipped around here. And then let's see, at about again, this is sped up as well 4 times. We'll start to see a couple little vortices over here on the rim as well. Like you can see these little wispy things. So there was these kind of little dust devil type things going on over here along the rim. But then we'll start to see some big ones develop here close to the vent as we go forward on this video clip here. You also can start to see some differences in color. The brown, of course, is the tephra. This fine, like Pele's hair, pieces of glass and lava. And then you'll occasionally see more of a bluish haze here. That's more of the direct sulfuric gases coming out of the vent. So here we are, about 3:41. I promise this will get exciting here in a second. I'm just waiting for, as you can see, the one right there on the rim, little vortice occurring there. You can see some of the differences in the color there. There was a little bit of that blue gas there for a second. So there's different color contrasts in just the material that's in the air. And then as we get going a little bit further here, let me look at my notes. There's going to be some swirling tephra here in a few minutes, as well as we're going to see this sort of tight tornado form right next to the vent. You can see some of these small ones again over here on the rim of the crater over there. Again, just some really interesting wind dynamics and air movement there within the crater. Maybe scoot this forward a little bit. Here's some more of these kind of tephra tornadoes, I guess we could call them that. I mean, it's really whipping around little tiny pieces of ash, little clots of lava as well. Nice contrast there. You can see the blue again with the brown. So some differences there in the tephra and the gases, and then they kind of get all swirled together, but there are instances in there where they're somewhat separate. And then up here, I think at the 351 mark, 350, 351 is what I wrote down, is where we really start seeing some of this swirling really start to become really interesting. Just really crazy, just wind motion here. Here's this another big swirling mass over here. Let you kind of enjoy that here for a second while all this lava fountaining is going on. So I found this part of the webcam footage really interesting, just more from you can see the fine tephra. I mean, it almost looks like you can see some of these little pieces just flying out everywhere. So that was really whipping around. There's that nice tight tornado right there. We call that a tornado. Really gets going right there at ground level, just whipping that tephra all around. And again, probably caused by the wind shear and then the heat from the lava fountain and causing the uplift. So you've got wind shear, wind moving in different directions, and then the uplift, and that gives you this rotating column of air here. So another one right there that forms really nicely. And then you start to see, just kind of coming towards the camera, there's some of the blue, right? So there's the blue color. Just really interesting patterns here. And this just really kind of captivated me as I was watching this, record this and share this with folks. And then there's a big one coming here in a second. You see some of the tephra falling out of the sky. So now the wind is shifted around, that the tephra was actually falling pretty close to the camera. It looks like it's pretty fine. But at one point here, I feel like the camera kind of takes maybe a little bit of a hit, but it keeps on going. Again, the colors there's some of the sulfur-rich gases coming out. And if you can hang with me here, as we have this sped up sequence at 4 times speed, around the 357 mark, there's a really nice big swirling cloud there. Again, look at all the tephra falling down just right towards the camera there. So the wind had shifted around and was blowing this tephra and fine material right near the camera. Right here is where we should start to see, yeah, here's this big one start to form here. So look at this tornado. Here's almost like partially in the vent, and it's whipping some of that lava material around. Just really impressive. It's completely obscured the vent right there. You can't even see the vent through this tephra tornado, I guess is what we might call it. We've seen these on the lava floors before where they're ripping up chunks of the lava, but this is out here where we have all of the loose debris and tephra from this eruption. Just fantastic. Really cool. So I hope you enjoyed that. And I was lucky to be able to just record that when that was happening during episode 37. So I just wanted to share a couple quick little clips with you. I hope you found those super interesting. Let's go ahead and look at the, it's over. Let's look at the latest update here from the USGS. So this came out last night, right when the eruption ended. They give some of the specifics here. Again, it ended about 11:39 Hawaii Standard Time. Let's see, no lava fountains or flows erupted from the south vent during episode 37. So that makes it a little bit different than what we've seen with some of the other ones. They do have some estimates on the size of the eruption. So fountaining lasted for about 9.2 hours and produced an estimated 8.2 million cubic yards or 6.3 million cubic meters of lava. This is actually quite a bit smaller than the previous 3 eruptions, which were quite a bit bigger. They ranged anywhere from about 8 to 10 million cubic meters. So this was a markedly smaller eruption in terms of total lava output. Lava flows covered about 75% of the crater floor. Some of this stuff here. And then as soon as the eruption was on in full tilt, we switched from an inflationary trend with the tilt meter to more of a deflationary tilt. And I'll show you that here in a second. So they'll probably put out another one today once they kind of get up and going there over on the Big Island, and they'll have a little bit more information, I'm sure, in the next one. This one was basically summarizing briefly this episode 37 in terms of when it began, when it ended, and some of the numbers there. Some of the recent images from the USGS, they've gone down onto the crater floor with a helicopter and actually taken samples of some of this recent lava. Now, this one's not molten. You can see the geologist there not have gloves on. If this was still molten and glowing, there'd be no way your hand could be that close to it. So this is stuff that's pretty well solidified and cooled. Sampling some of that. Let's see, anything else that struck me from the images here. Oh, let's go to a different here. So there's the geologist out on the crater floor. The vents are over here. You can see some of the sulfur deposits there on the downwind side where this tephra cone is being built. And actually, I wanted to show you that picture here. So in Hawaii, we call a hill a pu'u. And so we have this growing pile of tephra on the downwind side. Remember, our 2 vents are like nested right up against the floor of the crater, up against the wall. And so on that southwest side of Halemaumau crater, from these 37 eruptive events over the past year or so, we've actually accumulated so much material that it's built a topographic feature here, a hill, or what they would call in Hawaii, a pu'u, of material. You can actually see the tracks here from the scientists that go out to this area to collect material out on this hill. So vents are down here. This is the crater here. We're pretty much looking, I guess, here like south or maybe a little bit southwest-ish. And then you can see that growing hill here. So every time we get one of these eruptive episodes, adding more material to this hill. Who knows how long this will all last, of course, but it is dramatically changing the topography there at the summit of Kilauea. A couple of videos that caught my eye. This one's probably the one I want to look at the most. This one's looking back at episodes 34 to 36. This is a time lapse. So this is actually going to show us the last 3 eruptions. So episode 34, just as a quick review, this began on October 1st. So really going back here, I guess 2 months or so. Episode 35 began on October 17th, and episode 36 was November 9th. So this is all sped up. Just within a minute or so, you'll be able to see all 3 eruptions taking place. Here's our time lapse, October 1st. Here's episode 34. North vent going first. South vent joins in the fun. Those are happening at night. And then you can see the fountains getting smaller and smaller, go into the morning, and then it just shuts down quite quickly. I'll show you that here with the recent one as well. Episode 35 had the tallest fountaining, so north vent starts, south vent joins in. Wind changes direction, so it gets a little bit kind of weird in here. But this had fountains up over, I think, about 1,500 feet or 450 meters. So this has been, just from a height perspective, the most spectacular of the 3. Now we're on November 9th. Here's episode 36. Again, north and south vents going off together. Had very close heights, so I think a little over 1,000 feet or 300 and some odd meters. That one can. And then it's run on a loop here, so it's going to start back up and show. We can watch it again. This is good. So episode 34 again, if you missed it. North vent, then south vent on October 1st. Into the morning, Mauna Loa there in the background. Episode 35, north vent starts, south vent joins. This one had some of the highest fountains. All the eruptive episodes, mostly a nighttime eruption. Did sort of, I think it was all a nighttime eruption. And then November 9th, which started out in the day. I think this one was all in the day as well. Fountains there. So that was pretty cool. So nice view there of those 3 eruptions. Oh, I do want to show you the waning phases of the current eruption. So we go back to V3, go back to this night. It to I just want to show you how quickly these eruptions die down. And I did see this with my own eyes when I was out there last year in February for episode 8. We were watching it, and within just a few minutes, it went from fully erupting to not erupting at all. So I'm trying to find the correct timestamp here. You can see it erupting quite nicely. This is about 10:30 at night. Forward, we're about 11 o'clock. And I'm looking for about 11:30. A little bit. Almost there. Okay, so this is probably close enough here. And let's go ahead and speed that up to 4 times speed. And this will show you. So here we are, 11:38. You can see the time at the top left there. Let me make it bigger for you. And then watch how quickly this all just kind of dissipates. So lava still being jetted out of the north vent, flowing out onto the crater floor. We are at 11:39. Now the fountains are getting a little smaller. A little less fountaining going on. Less. Now we're at 11:40. And the fountaining is over. And just like that, the eruption is over. There's still lava flowing out because this material is still molten. But it can die down just that quickly. So these eruptions can really be turned off quite quickly and abruptly. I find quite fascinating. Okay, so last little bit here on looking at the monitoring data. So here is the tilt meter. This is just looking, this is while the the tilt was going up, and then the event started yesterday, and you can see the deflationary tilt occur. But then you see this big spike here. We'll come to this in a second. There was actually an earthquake unrelated to what was happening up at the summit. It was a magnitude 4.6 quake on the south flank of Kilauea, completely unrelated, and we'll look at that here in a second. But because of that earthquake's energy, you do see a little bit of a spike there. Looking at the tilt meter over the past few days, you can see that inflationary tilt kind of just very gradually going up. Then the eruption begins. We go to a deflationary tilt, and then that little earthquake kind of spikes in there. Goes up again on this one as well. But again, the same sort of pattern we've been seeing over the past year almost, of this sort of sawtooth pattern of inflation, eruption, get a deflationary cycle. We start storing more magma in the conduit, so on and so forth. And then let's see here. Yeah, here's the crater floor elevation. So you can see when this eruption, episode 37, occurred. That brought the crater floor up about 2 meters, so almost 6 feet, just pushing lava out to the surface. That actually built up the crater floor to about that amount there. There's that big earthquake there. I'll come back to that here in a second. So here's the Kilauea summit up here. This is the south flank area. Here's the east rift zone over here. But notice there's a lot of earthquakes that happen here anyway. This portion of Kilauea is unsupported. The ocean erodes at its sort of unstable base. Remember, all these volcanoes and lava flows went into the ocean at some point, and that creates a very rubbly material. It's not very strong or cohesive, and the sheer mass of Kilauea unbuttressed on this side means that it actually starts sliding towards the ocean. A lot of these cliff faces you see here are actually fault scarps, and so earthquakes here are very common in Hawaii because of unsupported nature. South flank. There's that earthquake in terms of depth, so about somewhere between 5 to 13 kilometers in depth. Just earthquakes overall, background levels. Again, the earthquakes, aside from that one interesting one, earthquakes just aren't happening at a very high rate because we have a clear opening conduit that's been established to the surface. There's really no magma being pressurized, backing up in the subsurface, and then breaking out. So there's the earthquake with a little bit different view. So the Kilauea summit area up here where all the activities taking place, and then East Rift Zone right here, and then that South Flank volcano, which people did feel. I think there was initially maybe about 200 reports. I'm sure it's higher now. Yeah, 445 responses. So people did feel it on the Big Island. Probably not over on Maui, but on the Big Island it was felt. But with a size of 4.6, not expecting any damage or injuries or anything like that. So pretty interesting. So we'll keep checking on Kilauea as time moves forward. The USGS analysis that comes out today should give us a better feel for what we might be seeing in terms of how long till the next episode 8. Based on what we've seen the last few eruptions, that's probably going to be at least 2 weeks away and maybe closer to 3. So we'll just kind of have to see how all that plays out. That would put us somewhere, I guess, mid-December-ish, if I had to guess right now. But I'll be with you with more updates moving forward. Hope you enjoyed this update and appreciate your support of the channel. There are links under the description where you can donate to our geology education videos if you're so inclined. And have a great day. Thanks, everyone.